Hello students, this is Ms. Dalton, and this week's video is on application problems regarding piecewise functions. Okay, first let's start with a review of last week's information. In this week's lesson, you are going to have to graph piecewise functions, but they're going to be from an application problem, so you're going to have to write the equations first and then be able to answer some questions about it. So in this first example, we're going to review how to just graph it given a piecewise function. So the first part of the function says that f of x equals 2/3 x plus 5 when x is less than -1. Now, we would normally start with our slope and with our y-intercept. Our y-intercept is this 5 right here, and our slope is 2/3. So if I graphed the y-intercept first at 5, then I would go up 2 and to the right 3. However, because it says it's all the x values that are less than -1, -1 is right here on the x-axis. So I'm going to go backwards, which means I want to do the opposite. I want to go down 2 and to the left 3. So I'm going to go down 2 and to the left 1, 2, 3, and then put a point. I'm going to do it again, down 2 and left 1, 2, 3, and put a point. Now it's going to be all the x values that are less than -1, which means when x is -1 right here, I need to go up to a line and approximate where that is, but I need to approximate it with an open circle. And then I'm going to go and I'm going to erase now this dot right here. Again, it's all the x values less than -1, which means I need to start at the point where x is -1. Okay, so now I'm going to go ahead and just connect those dots. All right, now the second part of my function says f of x equals -2x minus 4. So my slope is -2 and my y-intercept is -4. And this is going to occur when x is greater than or equal to -1. So my y-intercept is -4, so start with that on your y-axis. Then, because my slope is -2, that's -2 over 1. So I'm going to have to go down 2 and to the right 1, and so my point would be here. Then I go down 2 and to the right 1 again, my point is here. Now this occurs when x is greater than or equal to -1. So if I continue going to the left of that y-intercept, so I'd have to go up 2 and to the left 1, my point is going to be right here. So when x is equal to -1, the y value is -2. That's going to be a solid point because it has this line under it. Okay, so if you have a line under it, it's going to be a solid point. Otherwise, it's going to be an open point. And so I'll connect those dots. Not a very good straight line, but you get the idea. Okay, moving on to example 2. We have this piecewise graph that now we're going to write the equations for. So if we look at the line on the left, this line right here, we want to pick 2 points and find what the slope is. So I'm going to pick the end of that line and put a point there. And then I'm also going to choose this point right here. Again, it doesn't matter what point you choose, but you want to choose a point that goes through a solid point. You don't want it to be like going through at -3.4 because that would be too hard to find the slope. So from these 2 points, you're going to count the rise over the run. So if I go from the bottom point up to the top point, I have to rise 2 and run 1. That's going to give me a slope of 2 over 1, because again it's rise over run, which just simplifies to 2. Now if I continue to rise 2 and run 1, and then do it again, rise 2, run 1, we're going to see that if this line continued, the y-intercept would be up here at 9. So for this line, my slope is 2, and my y-intercept is 9. So my equation is going to be 2x plus 9. I'll come back and I'll do the restrictions in just a minute. Moving on to the second line, which is this horizontal line right here, when you write the equation of a horizontal line has a slope of 0. So what the equation is going to be is just y equals whatever your y-intercept is. Well, my y-intercept is 5, therefore the equation is going to be y equals 5, but notice you already have y equals in, because f of x is the same thing as y, so all you have to put is just 5. Now let's look at the other line, this line right here. So let's count our slope. So if I start at this point where it starts, and I find another point, another solid point, which would be right here, I need to count the slope, which would be the rise over run. So I count 1, 2, 3 for my rise and run 2. So my slope is going to be a rise of 3 and a run of 2. Now, if I continued this backwards, then I would get here, so it would have a y-intercept of 2 if that line continued. So the equation is going to be your slope, 3 over 2, then x, then plus 2. Okay, now let's go ahead and let's write what our restrictions are. For this first line, if I drew a dotted line down to the x-axis, it's going to be at -2 and everything to the left of -2. That's going to be all of your x values that are less than -2. And then you have to decide, do I need a less than or a less than or equal to? Well, on this first line, we can't really see the points, but as long as you don't include an x value in multiple lines, then you're good. So on this first one, I'm going to include that x value of -2. So I'm going to say x is less than or equal to -2. Then when I start my second line starts at -2, but I'm not going to put that equal to. I'm just going to use the less than. And when you write your between statement, because this is definitely a between statement, it goes from -2 up to 2, and it's all of these values in between there. Okay, well that's a between statement. When you write a between statement, you'll always put x in the middle, and it will always be surrounded by less than. You will never put a greater than, okay? That will not happen. So you will always have a less than there, okay? So keep that in mind as you're filling out your answers for this week. If it's a between statement, it will always be this less than, because we write our numbers from least to greatest. So obviously our less number is going to be here and our greater number is going to be here, so we need those to open up towards the greater number, which will always be on the right side. So I'm going to put a 2 here because again it goes from -2 here to +2, right? That line is between those two x values. All right, now let's look at the green line. The green line starts at 2, but then it goes on forever. So if I write my x values, it starts at 2, but then it goes on forever this way, which would be greater than. Again, we didn't. Oh, and one thing I should say, on the 2, if you're going to include the 2 in the previous one, so let's say I put a less than or equal to there, then in this next one, I would not put a line. But again, it's actually okay if you don't include it in the blue, but you do include it in the green. I just tend to always include it in the previous one. So this is going to be all of our x values greater than 2. And there's your piecewise function. All right, let's move on to example 3. I'm going to have to talk a little bit faster because I've already got the video at 10 minutes, and I know y'all are not going to be happy with that, so let's go a little bit faster on this one. Okay, so for example 3, a taxi charges $5 minimum to ride up to 3 miles, and then it charges 50 cents for each mile beyond 3. Write a piecewise function to represent the situation. The first thing you want to do is you want to identify what your x and your y values are going to be. My x is going to be the number of miles. My y is going to be the cost of the trip. Okay, now I put this table here. You don't have to use the table, but sometimes I like to just be able to plan out what I'm going to use for my equations. Notice that a taxi is not going to charge you at 0 miles. So when your x value is 0, number of miles is 0, your y is going to be 0. Okay? But then as you get in the taxi and you go up to 3 miles, you just have a flat fee of $5. Okay? Then as you go further, so then as I go to 4 miles and up, I'm going to have to pay that $5, but then I'm also going to be charged 50 cents for each mile beyond 3. Okay, so I want you to pay attention to how I'm doing this. So it's 50 cents, so 0.5 cents for every mile beyond 3. So what I need to do is I need to take my x and I need to subtract 3's. Because think about it. If I went 4 miles, I'm only being charged that $5 for the first 3 miles. But then after that, I'm going to get charged 5 cents or 50 cents per mile. Well, I need to subtract 3 because I've already been charged for those 3. So I'm subtracting 3 to figure out, okay, 4 miles, I've got an extra mile that I'm going to get charged 50 cents for. So you're always going to have to do that x minus whatever the previous number was. And then we have to add on that minimum of $5. Okay, so this is our equation, but we don't want to write it like that. We want to simplify it. So we're going to have to distribute the 0.5. So we have 0.5x minus 1.5 plus 5. And then go ahead and combine your like terms. So 0.5x plus 3.5. So that's our equation for the second part of our function. All right, so let's go ahead and write our function real quick. The f of x, or the y value, is going to equal 5 for all of your x or your miles that are between, so we've got our between statement, we got less thans, between 0 and 3. Then we have to decide, is 0 included or is 3 included? Because we've got to put lines under the less than if so. Well, remember, at 0 miles, you're not getting charged anything. So you don't want to put a line under the 0, okay? But on the 3, it says up to 3 miles. So at 3 miles, you're still getting just charged that $5. So you do want to put a less than or equal to on the 3. Now, moving to the next equation, we've already got our equation right there. It's 0.5x plus 3.5. And this is for all of the x values above 3, so greater than 3. And another thing that you can do is you can always plug in some numbers to see if you've got the equation right. So let's say I want to take this value of 4. We know, based on the function, it's going to be $5.50. That's what it should be, right? Because we're being charged 50 cents per mile above 3. Well, that's 1 mile above 3, which is 50 cents. If I add it to that 5, it should be $5.50. Well, if I plug in 4 here, let's just see if it works. 0.5 times 4 plus 3.5. 0.5 times 4 is 2. and then 2 plus 3.5 does in fact equal 5.5. So you can always test that with your equation because you know what's supposed to happen, but getting that equation right here is sometimes hard to do. And then the last thing you could do is you could graph it. Again, on the assignment, I'm having you match the graphs and write the equation. So I'm not going to spend some time going over the graphs because we've done that many times. Okay, moving on to example 4. This has to do with overtime. So those of you that have a job where you get paid overtime, this will help you, and hopefully you'll understand some of the verbiage here. So it says you have a job where you make $18 per hour. What a nice job, $18 per hour. After you work 40 hours, you get paid time and a half. So you need to understand that that's meaning you get $18 per hour plus half of that. Half of 18 is 9, so therefore you're going to get paid $27 per hour now. Okay, this one you're just getting paid $18 per hour. Okay, and then it says you may only work a maximum of 60 hours. So let's go ahead and identify what our variables are. X is the number of hours worked. And then Y is your pay. Okay, so let's go ahead and make a table of what this is going to look like. So if you work 0 hours, obviously you're going to get paid 0. Okay, but then if you work 1 hour, you're just getting paid that $18. If you work 2 hours, you get paid another $18, so that would be 36. So this is going to continue all the way up to 40. 40 hours a week, if you multiply 40 times 18, that means you're going to get $720. All right, all of this can be represented as the equation 18 times the number of hours, so X. Okay, well then, as we move up, and now we're going to start working more than 40 hours, as we work 41 hours all the way up to our maximum of 60, we're going to get paid time and a half. Now, remember from the previous example, you want to do the time and a half, so $27, times, but we need to subtract out those 40 hours. The 40 hours you were only getting paid $18. Everything above the 40 hours, now you're going to get paid 27. So we need to do X minus 40 to see what above 40 hours we worked. And then you're always going to add this value. So the previous value gets added on to the end. Now we need to go ahead and simplify that. So we need to distribute the 27. So that's going to be 27x. 27 times 40 is, and minus there, minus 1,080 plus 720. So then if I add that up, now collect my like terms, 27x, if I add these, that's going to give me negative 360. All right, so let's go ahead and write this over here on the left side. So the first part of my equation is going to be 18x. Now, think about, when are we getting paid $18 an hour? Well, we're getting paid 0 when we work 0 hours up to 40 hours. Now, at 0 hours, we're not getting paid, so we don't need a line there. But at 40 hours, we are still getting paid that $18, so we need to have a line there. Now let's move to our second function. Our second equation is going to be 27x minus 360. And that's going to be when x is greater than 40 hours. Now, do I need a line there? No, I don't, because at 40 hours, I'm getting paid $18 an hour. Anything above 40, so like 41, that would be this second function. So I do not need a line under the greater than. Okay, and there is, oh, I realized I just made a mistake. Let's go back and let's write our restrictions on this last one, sorry, because the maximum can only be 60. So I forgot to include that. So this really needs to be a between statement, 40 up to 60, and the 40 would not have a line, but 60 would have a line. Okay, I forgot about that maximum part there. All right, so hopefully that makes sense to you. All right, next example. Home Depot charges $20 a day plus 15 cents per mile to rent a pickup truck. Home Depot offers a discount of 5 cents a mile if you drive over 10 miles a day. Or they offer a discount of 10 cents a mile if you drive over 20 miles a day. Write a piecewise function that represents the total cost. Okay, so first identify your variables. My x is number of miles. Now, if you want to pause the video at this point and try this on your own, do that, and then you could come back and press play to make sure you got it right. So the y is the cost to rent the truck. Okay, let's go ahead and fill in our table. So they're charging $20 a day plus 15 cents per mile. And it says, and really that's going to occur up to 10 miles, because at 10 miles, now you're getting a discount of 5 cents. So from 0 to 10 miles, we're getting charged that $20 a day plus the 15 cents per mile, and the number of miles is X. Okay, then from 10 to 20 miles, because again, it says 20 miles, then we get another discount. Well, this is after 10 miles, we get a discount of 5 cents. We're going to take away that 5 cents from the 15 cents. So now we're getting charged the $20 a day, but we got that discount of 5 cents. So now it's going to be 0.10x. We're just going to take away that 5 cents. Then anything above 20 is now going to be charged $20, and you're going to get a 10-cent discount from the original, so now it's 0.05x. Okay, so let's go ahead and write these equations over here and get our restrictions. So the first one's going to be 20 plus 0.15x, and that's going to come from 0 to 10. So that's going to be a between statement, 0 less than x less than 10. At 0, we're not getting charged anything, so don't include 0, but you do need to include 10. Okay, then the second equation is 20 plus 0.10x, and that's for 10 up to 20. So a between statement again, 10 less than x less than 20. 10 was included in the red function, so we don't include it in the blue one, but we do include the 20. So the 20 needs to have a line under it. Then the last equation, 20 plus 0.05x, that's going to occur for all of your x values that are greater than 20. So anytime you go above 20 miles. And there's your function. Again, I'm not going to worry about the graphing so much, because on the assignment you're going to be matching the graph, and hopefully you can do that once you've got your equations. Sorry this video is a little long. Please do your assignment, and please join my Zoom sessions if you have any questions. Remember, I've got a Zoom session on Tuesday and Thursday at 10 o'clock in the morning, so please join me if you have any questions.